Are you trying to get Houdini creations into Unreal Engine? But does it always end up glitchy in Unreal? How do I get my custom character rigs to work nicely with Unreal Engine? And why would you even want to create character rigs for Unreal? Using Houdini? Making character rigs for games, for films, and even for profit. There's no denying Unreal is popular. Houdini can do procedural like no other application. Create hundreds of complex characters with a single setup in Houdini. That's like pressing a button. Imagine using that to generate a world of NPCs in your environment, or selling character rig bundles on the Epic Marketplace. But my rigs end up so glitchy in Unreal. Getting custom rigs made in Houdini to work perfectly in Unreal has very specific requirements. I've done so many trial and errors to finally forge a workflow process that I can share with you. Following my tips, you'll have a much better experience with your custom rigs in Unreal. The modular rig blueprint will be a click and drag, like how it's supposed to be. IK retargeting animations will work like a charm. The objective is to demonstrate what are the key parameters that you would need to pay attention to in order to get that perfect rig compatible with Unreal Engine. Now, I'm not here to show you how to create everything from scratch because that would overwhelm you. We'll start off with Houdini and a working rig with default values. Then step by step, we'll fix this rig up so that it becomes compatible with Unreal Engine and most importantly, compatible with the modular rig blueprint. This will allow you to understand the impact of each part we change and why we need to change it. In Houdini, drop down a ROP FBX character output node. That's the one with 3 input sockets. Then hook it up like you see on the screen. The parameter Unreal Engine preset that the blue arrow is pointing to won't really matter much, but I've indicated just for your information. Later on in the video, I'll show you what I find even though you have this enabled, you still have to fix all the joint orientations. So let's go back into Unreal Engine. Now here I'm going to make this full screen. Here I create a demo, a new folder with empty, and I'm going to drag our logo rig v1. That's the character rig that we just exported out of Houdini. The FBX import options for Unreal Engine, just click this reset to default. So we're just going to use the default settings. Now we can just close this. Now let's take a look at the skeleton mesh. Unreal Engine calls it skeletal mesh. So that's our character rig. Let's click these bones. You can actually test it out and see how all the FK controls or the bone controls. These are not FK controls, sorry. These are just bone controls. And we're going to right click this, create modular rig. Okay, so double click this file. This blueprint, it automatically tries to guess where the root bone is and it places this yellow hexagon there. And that's what the modular rig tries to do. It tries to automate as much as it can, but it doesn't recognize this root bone. Now I'm going to put this side by side with Houdini to show you what Unreal Engine is actually trying to convert from Houdini. So this is the bone that Unreal Engine is reading. It thinks is the root bone. We actually don't have a proper root bone set up here. And another thing is, let's go back to the Unreal Engine. Now let's go back into the skeletal mesh. It's over here. Now there aren't any material slots. There's one, but there's actually a lot of material slots attached to this character. Now let's head back over to Houdini. I have my materials information stored in the name primitive attribute. You may have it stored in any way or anywhere you want, as long as you are able to transfer or assign the material information to a string primitive attribute named FBX underscore material underscore name. This data being exported with the FBX is what Unreal will read as material slots. You'll see here that I'm using a primitive wrangle and assigning the FBX material name to the values in the name attribute, which is where I actually have all the material information stored. You may have it in a different form. Here, we're gonna create a proper root bone for our skeleton of our character. I'm using the add node to create a new point at the origin, which so happens to be where my character is standing, ground level. Using a point wrangle, I'm naming the point as root by assigning the string name primitive attribute to it using the point wrangle. And lastly, adding a rig doctor node, which is actually optional because parent joint node will automatically create the correct data for us anyways. I just got into the good practice habit to manually add the rig doctor node. So let's parent this guy up. So let's add in the parent. I'm going to choose root. In the joint, I'm going to choose my back 0. That's this one over here. So you can see that this automatically updates with the right skeleton change. Going back to Unreal Engine, in this demo folder, I'm going to create a new folder. I'm going to call it logo rig v1. I'm going to put all of this in v1. So we're a little bit more organized. Close this v1, close this v1. Create a new folder, logo rig v2. I'm going to come in here. I'm going to drop down that newly exported rig that we just created in Houdini and put it into Unreal. And again, reset defaults. It should remember the last settings. Now you can see that we have a lot more things here in the content browser. Oh, and these here, these white balls here, are the materials. So it instantly created the correct, or at least now we have material slots. Now let's double click this skeletal mesh and let's take a look. We'll have to recreate the materials. So the actual materials are not being ported over into Unreal, but we actually have the physical materials blueprints created. It was created for us, but it's just empty. I actually have textures driving these material slots. So a little bit more organization is that I'm going to come to the demo folder over here and I'm going to stick all the materials in here. Why would I do that? Is because we're going to have different versions of this local rig and I don't want to keep updating all the materials. Unreal Engine has a really nice feature of picking up the materials once it's created. Even if you have like a different character rig file, it'll still pick up these material slots. So that comes in really handy, especially when we have like different versions that we keep creating. I'm just gonna come here and create a folder called materials, and we're gonna stick all that in. All those white balls, this, and this. I'm just going to drag it over to that material folder that I just created. So it's all in here. The actual material creation is skipped in this video because it was getting long, but I'll make it available in the detailed version of this tutorial for Perk 2 members. Try to keep in mind that the detailed version is meant to be used for reference. If you get stuck on something, you can look it up quickly because I'll have each section labeled for each step, making searching super convenient. Now let's create a modular rig for this version 2. Now let's right click the skeletal mesh, create modular rig, and we're going to double click this. Sorry, I think I double clicked the wrong one. Control rig, double click this. There we go. Okay, this is the right one. Now you can see that the hexagon is now updated. The position is where I would like it to be. It is ground level with the character, which is important for me. And it automatically detected the root bone because we placed the root bone over here. So that's something that you need to be aware of. This is the backbone. So this is going to be the spine, the start of the spine. This is nicely labeled spine. Seems appropriate. Let's drag and then drop it into this socket. Now you can see nothing happens. Well, it creates a new module rig here. So we have a root and then we have the spine. So something did happen, but what we expect is that it automatically creates the next line of sockets. Now the reason for this is that it does not recognize this bone naming system. Goal here is to click and drag and that's it. Now it's not doing anything. I don't have sockets or anything. But how do we actually know what are the proper bone namings that Unreal Engine will recognize? Well, we can always go back to that UE mannequin that we know will work, or we know that works well with the modular rig blueprint. And that can always be like our reference. So if you come over here to the content, now I'm assuming that you added the starter content. And after you've added it, you should find it in your content, characters, mannequins, meshes, and we're going to take a look at skeletal mesh. So we can use this skeletal mesh as a reference. So we know what bones to name, a reference to the joint orientation. Open this guy up. And once you click this skeleton, you can see the whole hierarchy over here of the skeleton system for this rig. The ones that are grayed out, these are IK bones and extra things. In Houdini, rename the bones to match that of the UE mannequin. Try to keep in mind it's okay to have less bones compared to the mannequin. But if it's the left arm, the left shoulder bone needs to be named upper arm _ L. You need to align the names of the correct skeleton parts. Arm to arm, leg to leg. As you see here, I don't have any fingers at all. No twist bones, and if you look closely, I don't even have as many spine bones either. But it's important to note that the spine bones begin at spine _01, spine _02, and 03, counting from the pelvis towards the head. The last thing to note is that Unreal really likes prefixing the numbering with zeros. Like I said, spine bones, they are all prefixed with 0 and then the 1. 0 and then the 2, and so on. Let's come back over here, create a new folder, logo rig v3. Go in. Now we're gonna import this v3 that we exported out of Houdini, the new updated version. Now this time, these FBX import settings, they're gonna be a little different. Now they are still default, so I'm just gonna click this, reset to default. This is all default parameters, but there is something different this time. We do not want to recreate the materials because we already have them there. I want Unreal Engine to pick it up. And it says create under the materials section. It says create new materials. We don't want that. Create new materials, create new instance materials, do not create material. Just choose do not create material. And you can see that search location, it will search the local, so it will find it. So now we just click import, it should automatically pick up the material, so I don't have to keep reassigning them. Let's take a look at the skeletal mesh. Now this looks pretty good so far. The root, spine, upper arm, thigh. Okay, this looks pretty good so far. So let's right click the skeletal mesh, create, and create a modular rig. Now let's double click this guy. Now let's see what happens when we drop in the spine this time with the correct bone naming system. Let me just click this hierarchy so you can actually see the bone naming system. And here's the module hierarchy. Click the spine, drag it in. Now we successfully got the sockets to procedurally create in the modular rig, which is what it should be. This makes it incredibly useful because it automatically fills in the connector information for us as well. Now, if you don't know what to do next, if you just hover your mouse over these sockets, they actually tell you what to do. It's like place the shoulder module over here. Place the leg module over here. Now, this one we already have. The spine bone was the one that we did. And I'll tell you that you already have it here. Drop and drag the spine module here. We've already done that. So it actually has the connection. If you look carefully, it says connection, spone, primary. So there's something already filled in. So it's the tooltip will look a little different from something like this. So that's like a little hint to tell you that which one was already populated. So this is the end of the spine bone. Now let's place the shoulder bone over here. It automatically creates the hand socket. Very, very useful. And it tells you place the arm module here. So let's do that. Now, you'll see this doesn't look correct. So that's because our bone orientations are not matching that of the UE mannequin. They're not something that Unreal Engine recognizes. But let's finish this off first. So let's go to shoulder, arm, And again, same thing over here. That's incorrect. But let's finish it off just to see if there's any other problems that may arise. So we're going to click and drag the leg bone to the thigh. And look what happens. This is completely wrong. It started to deform the leg just because the IK is enabled. IK is automatically enabled for the foot modules. Let's go back to that UE mannequin to figure out what the orientations should be for each joint. Unfortunately, you have to click. Okay, I had increased the size too much, so let's Alt square bracket to reduce the size. And remember, you have to keep smashing that square bracket button while holding Alt. Houdini uses Y up right-handed coordinate system. Unreal uses Z up left-handed coordinate system, which really means the Y and the Z, they're swapped. And what gets even more trickier is that when you import your character FBX file into Unreal Engine, it automatically detects that it's Houdini and it's a Y up right-handed coordinate system. And it automatically swaps it for you. Now let's just minimize this. Go back to Houdini. That's what I meant by this parameter. And that it doesn't really help much to have it converted ahead of time, because when you pop it into Unreal Engine, it auto detects it and reverses it anyways. Now, a rule of thumb, the x-axis is always following the bone alignment. That will not change. That will not get swapped or anything, because x-axis is not something that it will get converted. X needs to point this way and not what it's pointing right over there. Let's do it one more time. Okay, so orient bones. So the reference vector is where the bone alignment is, and it's saying use the z-axis. That's why the z is pointing towards the z direction is in an alignment with the bone connection, but we want the x-axis to be in alignment with the bone connection. So let's change this to x. 0. That's gotten us a little bit further. Now let's look at that reference we had. This is the arm skeleton. So the left arm, this one. The Y is pointing forward. It's supposed to point forward. In our case, in Unreal, it points forward. But remember, when you import the FBX file, the Y and the Z are going to be swapped. So you have to think the other way. You have to think the reverse way. Y will be pointing this way in the Z direction, which is sort of upwards, perpendicular to the front, which is sort of upwards to the side, this way. And if we look at this, I mean, it's a little hard to look at like this because we only have one limb. So let's template the entire skeleton. Okay, that's a bit better. That gives us a bit more information of where the front is. So right now, Y is pointing upwards, sort of. This should be something that Unreal Engine would like a lot more. In this video, I'm only going to demonstrate fixing the joint orientation of one side of the arm. And again, the whole process of fixing both arms and both legs and the spine is in the super longer video that's available for Perk 2 members only. Create a new folder, logo rig, V4. Drop this in. And again, we do not want to reset it just because we already have the materials and I want it to auto assign. So let's take a look at the skeleton mesh. We actually don't need to. It should be fine. Because even if there was something wrong, we wouldn't see it here. So let's go back to here, V4. And what I'm going to do is right click this and create modular rig. And double click this. Oh, no, sorry, that was the wrong one. Double click this, the control rig. How do we test this? Let's just recreate it. It's just click and drag. Spine, drag it in. Shoulder, arm. And right off the bat, you can see that these circles are automatically procedurally generated in the right axes. So I didn't have to do anything else. This is what I'm trying to achieve. To have it as in Houdini as compatible as possible with the default values in Unreal Engine so that when we pop it in, it literally is just click and drag. Now let's just finish this off. So you can see this side is doing well as well, good. Now let's see the feet. Okay, you can see that it's doing much better than what it was before. Like before, it was actually deforming the entire leg. Now this pole vector, like I said, I don't know how to fix that. It is procedurally generated overlapping it. I don't know how about to fix that. I tried many ways. Now let's go back to the arm. Now let's click this arm here, go to the details, scroll all the way down, and let's enable the IK. And right away, you can see that it updates in the viewport. So we get this box. But our pole vector over here, this is still overlapping with the elbow. Now this one I can fix. I know why it's creating it like this, because this is a T pose. If you look at the mannequin character, this guy is in an A pose. Now, okay, this is a screenshot. Let me actually pull him up. This guy is in an A pose where his arm is being bent just a bit forward. Now let's head back into Houdini. Let's fix that up. Because the T pose is actually easier to procedurally generate in Houdini. So I like to keep the T pose, but I want to update the rest position. So we can do that using the rig stash pose node. Come over to the viewport. Press enter. Now we can update this. Now I want two views. One for the front, and this to keep in perspective. Now click this arm. Now we're going to change it into an A pose. But we still have another problem because our mesh is still in the T pose. So what we can do, or what I did was, I threw down a bone deform so I could get the mesh in the right position. Rest position would be before you do the update. Now we have an updated version of the mesh as well. I'm just going to label this. Again, a more thorough step-by-step guide is available in the detailed version of this video for those that get stuck at this point. Head back to Unreal. Now let's go back up here. Let's close all these V4s. We'll leave mannequin here. New folder. V5, drop that in. This should be second nature by now. I did this so many times. Like this is just 1 to 5. You should see my other version counts. Okay, let's double click the skeleton mesh. Let's check it. And we indeed have the A pose. So that's the only thing I need to check. Now right click this, create modular rig. Now double click the control rig to bring it up. Now let's do it again. It's only click and dragging. This is as simple as it gets. The circles look good, but before we continue, let's click this arm, come all the way down here, and let's switch it to IK. You'll notice a slight deformation on the left arm, and that's from some bad orientations created when I updated the character rig from a T pose to the A pose using the rig stash pose node in Houdini. It's not a big deal, just go back to the rig stash pose node and fix the orientations to match that of the Ewing mannequin rig, the one that we've been relying all this time to guide us through this journey. Even if it's not fixed, you'll find that the IK controls still work very nicely. That's because the weights are still the same. We've only updated the rest pose in Houdini using rig stash pose node. We never modified the weights. All in all, if this video was any help to you, you should have a nice working modular rig blueprint for your Houdini creations.